Good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends on from where you are joining the program again. Welcome to Big Bang Data Science Solution, the free training program in exchange for $150 donation to a church, masjid, family of needs, or NGO. Today we are going to talk about machine learning. So in week number one, we had a topic or a lecture on why you should become a data scientist, why you should learn data science. Then we talked about CRISP-DM, and this is the methodology, most used methodology in analytical projects. So we talked about this CRISP-DM, and we talked about the first phase of CRISP-DM. Of course, in a nutshell, this is a 30-week program, and of course, we cannot go over everything in 8 weeks or in 10 weeks. Then in session number 3, we build a foundation on programming with Python. Then in week number 4, we talked about phase number 2 of the CRISP-DM, and that is data understanding. Then we, in week number 5, data preparation, and we had more than a session in data preparation. I believe we had 3 sessions, data preparation 1 and 2 and 3. And just data preparation requires a lot of hours, a lot of effort. Unfortunately, we did the best we can, and because of the time limits, we had to focus on few things rather than doing everything supposed to be done with this data. So now we got data, it's ready, it's all good to go, and now we are going to move into week number 6, which is going to be supervised learning classification, and that is machine learning. So now we have the data ready, and we are going to apply a machine learning on this data, trying to learn a pattern and apply that pattern on any future incident or future claims that would the business receive in the future. Okay, so we are still working for this our insurance company as data scientist or data analyst, wherever you name yourself. And we know the problem. The problem with this company is they are losing money because of the fraudulent claims. And they brought me and you, they brought us in as data scientists to help them stop or fight or put an end to the loss, the money loss due to fraudulence. So this company, what they do, they actually have a solution in place. Unfortunately, that solution in place is not covering. It's a random solution. It's not actually covering all the cases. And so the business problem, they are losing money. They are losing money because of the fraudulent, as you see. And they have a solution. They have a team that investigates up to 30% of all claims made. Unfortunately, this team only investigates 30% randomly. We don't know what is in those in this 30%. It could be all fraudulent claims. It could be all legitimate claims. So since it's random, the outcome is going to be random as well. So they brought us in to fix this problem. So we started with business understanding. Number 1, this is the first step using CRISP-DM. Then we moved into data understanding. We understood the business. Now we are going to spend time understand the data. And to understand the data, a few things that you need to do. Number 1, apply ADA, data visualization, statistical analysis, and create or design or develop your own code book. And the code book is a technical, is an overview, is a document, an overview documenting the quality of your data. What is in your data? And this code book or quality report is what we are going to use in the third phase. So this is, excuse me guys, this is a typical quality report. It does talk about what you have in the data, the type of the variables, the storage, transformation method, the problems, etc. So it has as much as you have, as you can obtain, as much information as you can obtain on your data. And this quality report is what we are going to use in phase number 2. So we are going to use this quality report to process our data. And in data preparation, we have to deal with missing values, outliers, cardinal or hierarchies. We need to convert categorical into numerical. We need to transform numerical data from one position or one state to another state through applying normalization, factorization, binarization, standardization, correlation analysis, and of course we need to engineer features and select features, and we need to have a better version of the original data set. So we need to have a better version. And now we have a version that we are going to need, and the next step is, sorry guys, next step is, where is it? Next step of the process is modeling, is the modeling or machine learning in general. So what is machine learning? Okay, I will try to explain machine learning very with an example. Yeah, try to explain machine learning with an example. So let me stop here. Trying to explain the concept of machine learning using 3 images. So machine learning is simply a boy or a girl. Now, 3 years old, 2 years old, 4 years old is a baby. And this a boy or a girl, out of the curiosity, we the kids at this early age, they experience, they explore the environment. This is the best age to learn. Of course, if you leave a child somewhere in an environment, of course they are gonna try to attach everything, get items in their mouth. It does not really matter. They don't care if it's poisonous. They don't care if it's hot, if it's deadly. They really don't care. So they explore anything, everything, anything. They could put in their mouth any object they are they could get hands on. So this baby was walking on the in a room or in the floor, and he saw a candle that is shiny red, flammable, shiny and red. Okay, and out of the curiosity, the boy put the finger on the flame. And from this incident, of course, the child is gonna back up because he's gonna burn and he'll get burned. He'll get hurt. So this child will learn from this incident 2 things. He will learn the object, which is in our case candle, or he would learn the patterns. In our case, anything that is red and shiny is pain. Okay, so the child could learn anything, 2 things out of this incident, and the same with us. We could learn anything from incident. Either memorize the object as is. So we are going to visualize that anything that is white, then got a black, what do you call it, thinny or rub in there, and you got a flame, stay away from it. Or it can learn that that is anything that is shiny, and shiny and red, it's a pain. Do you guys think about anything else that the child would learn from this incident?
Next time, like if he sees something like that, he or she
No,
doesn't
no.
go
My
there.
question is, do you think anything else that the child would learn from this incident? There are two.
That it's hot.
That is pattern. Either learns that anything that is red, shiny, hot, white, is painful, or is going to learn the memorize the object. So the same
Anything
child.
red, shiny,
Sorry.
anything like that is red, shiny, like he's gonna think it
No, I mean
hurts.
he's learning two things. Either he's learning the object or the pattern. The question is, do you have anything else beside the object and the patterns that the child would learn from this incident? I don't think so.
I don't
There are
think
two.
either.
Either the
For
object
their age.
or
For
the
their age, I don't think so.
okay. So the same child, it's your child, your baby. Next day, was walking on the in the kitchen, and he saw the gas burner or the stove, the top. So, and the stove is again is flammable, is shiny, as you see, and red. If the child, if the child learns the object from yesterday incidents, what do you think he's gonna do?
Away.
Say again?
Don't touch it.
No, it's object, brother. If the child memorizes or learns from yesterday's incident, memorize the object, what do you think he's gonna do?
He's gonna touch it again
Yeah, I will try to touch it again. Why do you think he's gonna touch it again?
because it's a different object.
It's a different object. If the child is, if you are giving anything, you're giving anything deadly, it's different than yesterday object. Of course, the child is gonna do it again. And guess what? What's gonna happen? He's gonna hurt himself, right?
Yeah.
He's gonna.
That's correct.
Yeah. And the next day, if you bring anything that is the same, a different object, is deadly, is gonna try again and keep trying. So the child is not actually learning. The child is memorizing. He memorized the object. If you got hit, if you cross the road, you got hit with the car, with the red car. And if you memorize the red car, tomorrow you are gonna cross the road again, and you could get hit. You'll be paying attention to red cars, but there are other cars that are not red, white cars, yellow cars, green, blue, whatever. Then you could get hit again by a car that is not the same color as the yesterday incident. So what do you think would happen if the child remembers or learns patterns from yesterday incident? That is, anything that is red and shiny is pain.
Correct.
What is going to happen?
They won't touch the fire again
Won't touch it. Why?
because they know the pattern. Anything red,
The pattern is the same. And that is machine learning. Machine learning, we are gonna give data to machine learning. Machine learning could memorize your data, memorize the position of rows, position of columns. It memorizes the exact values of your data. If the machine learning memorizes the data, tomorrow if you give it a different data, of course it's going to do very bad, because the new data that you are given is totally different than yesterday's data. So the machine learning is not gonna perform better. But if we were to give a machine learning a data, and we are gonna leave this machine learning to learn on its own, and it learns patterns. The mathematical patterns is simply mathematical relationships within your data, the signals, the on and off within your data. And of course, if you were to bring a new data set, the model is gonna do better. So that is machine learning in a nutshell. Simply giving a data to a system, and the system is gonna try to learn patterns. Of course, this machine learning could do a mistake. It could, instead of learning the patterns, it could simply memorize the object, memorize the data. Okay? Any question, concerns about this?
I'm good.
So the question now is the child, let's assume that the child learns patterns. That is anything red and shiny is a pain, right? What is going to happen to the child if we were to give a shiny red toy for his or her birthday?
I think he thinks the same thing, like it might hurt if he learns the pattern.
No, so the child learns learns pattern. That anything that is shiny and red is a pain. Stay away from it.
Yeah.
And the next day you brought your child a shiny red toy for his or her birthday. What do you think is going to happen?
I think since it is the birthday, he's gonna try again.
No, ma'am. I don't think you are getting the picture.
Oh, okay.
We'll stay away.
Stay away. Why?
Because it's red and shiny and
It's red and shiny. So why the child now, since he learns the patterns, the child is going to stay away from those patterns, is going to apply those patterns regardless of those patterns are good or bad. In other words, the machine learning that learns patterns from a data, we are going to use that patterns to make a decision on new data set. But if that data set is good, the model is going to make good prediction. If the data set is bad, the machine learning is going to make a very bad prediction. In other words, the machine learning makes machine learning techniques make mistakes. So your prediction is not 100% prediction. It's simply a probability, and there is always a room for error. So what is the difference between machine learning and programming? Can anyone give me an example of programming? With the example of a child. How would you program your child if you were to?
If it is hot, do not touch.
Here we go. So programming, you are going to tell your child, hey, son or girl, don't come closer to a candle. You are going to burn yourself. The gas burner, you are going to kill yourself. This is poisonous. Do this, do that. Don't do this, don't do that. You are actually taking the freedom. You are simply overriding your child's freedom of choice, and you are programming the child to do certain things. You could create a program that looks into the candle, and if anything that is similar to the candle, avoid. Anything that is not similar to the candle, just use it. But this is programming, and there is no freedom. Machine learning, they have that freedom to learn on their own, and based on what they learn, make a prediction on future incident or behavior. So I hope the concept of machine learning is clear. Okay, any questions, concerns, please? Yeah, any questions, concerns, please, about the concept of machine learning?
Good.
How about others? Z, Sayyid, Shamsul, Shahid, Salih.
So it's Mohammed. I'm fine so far. Thank you. Thank you,
Yeah.
Mo.
Okay, so that is.
I have a question. So, so in programming, you are providing some information, but in machine learning, you are letting it learn by itself. You're not giving it any rules. You're letting it learn based on its experience.
Yes, in programming, you are telling it what to do and what not to do. If this,
in other words, can we say that the programming is a predetermined thing?
Yes, if age is less than 50, do this. If age is greater than 45, do this. So you are giving it some logics or some instruction of what to do and what not to do. Whereas in machine learning and programming, they are going to be most likely are going to have the same, except that in programming you are providing the instruction. So we have in the programming we have the data, we have the program, and we're trying to come up with an output. In machine learning, we have the data, we have the output, and we are trying to come up with the program, with the parameters, with an algorithm.
So I have a question. Like,
Yeah,
if
Safir,
you don't, if you don't think that answer would be appropriate at this stage, please ignore it.
Safir, please hold on, brother.
Okay.
Please hold on. Sister will ask a question. Are you clear?
Yes.
Good. Okay. So, Safir, it's your turn. Safir, sorry.
So it looks like there are different parts in this. Like, the one thing is the pattern, and the other thing is like the command also. So we have to identify the pattern also.
No.
And we have to, no?
No, the patterns are hidden. The patterns are there. You don't see them. You discover them.
Yes. So that's what I'm saying. So discovering the pattern is also the part of program or no?
If you hard code, then it could be a part. But we don't know the patterns yet. We don't know. You could know the patterns. You could guess a pattern. For example, let's say that you are working for Walmart and you're trying to predict a patterns that let's say, for example, you think that there is a pattern of clients age 60 years old plus. So these clients or these customers, they are 60 years old. They don't purchase beers, for example. Okay, you could guess and you program and you find anything. You didn't find anything. Whereas machine learning, it could find that all age 60s, they don't purchase beers. Age from 50 to 60, they shop in the morning. Age from 18 to 30, they shop on the weekends. For example, these are patterns. We don't know them. You cannot program them. You could program them if you know them from the previous experience. But
that is exactly my question is.
Yes.
Like the hidden patterns, how would we identify it? Like the program would do it, or
learning will find them.
Okay. And then we need to store those patterns somewhere and then apply those patterns to the decision?
Once machine learning find those patterns, and the question that would come to your mind is how good this finding, how good, how accurate.
Okay.
So we have a data. Let's say that this is all our data. Okay, this is our 6 million records, and this is our 100% data. Okay, we are going to feed this data into machine learning, and the machine learning will come up with some patterns, but we don't know how good or how bad these patterns are. And of course, we cannot use these patterns yet. So what we have to do, so this data is called historical data. Historical data.
Can I ask a question during this?
Yes, sir.
So you say that we are applying this 60 million rows to the machine learning.
Okay.
So the machine learning is a program.
Now, machine learning is an algorithm.
It's an algorithm. Okay, so it's a program. So that algorithm is created by whom?
It's math, but we convert the math is a function, mathematical function, converted to Python library or R library. It's still a program, but it's all math.
Mm-hmm.
So it's math. It's x plus y divide by this, do that, find the mean. In the programming, you are using some logic. If this, do that. If that, do this. So that is different. Yeah, the machine learning is an algorithm. Is all mathematical algorithms that have been transformed, translated into Python codes or R codes or Java codes or whatever programming language codes. Okay, Safir, are you clear?
Okay.
So we are going to feed. Yeah, we are going to feed this 100. We are going to feed this 100% data into machine learning. Machine learning is all math, all math. You need to worry about it. Really, I don't. I really don't care about the math behind it, but it's complicated math. Unless you have a mathematical background, it probably won't be. You will struggle like me understanding the concept, the mathematical concept. So, and this machine learning, which is only math, is going to handle these numbers, and numbers, they are math, values, mathematical, they are numerical values, and we are going to find a pattern, but we don't know yet how good or how bad this pattern is. So what we could do is we are going to split this data randomly into 80% and 20%. For example, this is one way to learn from historical data is we are going to apply machine learning on 80%, and we are going to test this pattern. So we are going to find patterns, how good they are. We are going to test them on 80%. Then we are going to come up with a big picture. Okay, that is what we are going to do. And when we are talking about machine learning, there are 4 types: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, reinforcement machine learning. So what is supervised machine learning? Is a data where we already know something about our data. We have an output. Okay, let me pause here. So this is 1,000 claims. This is historical data. We have in this historical data, we have 1,000 claims. And we already know that these claims, they are either fraudulent or legitimate. So we got the data from many different departments, different resources, different part of the business. And we have one feature, and that is called target variable. And this target variable is simply a column providing information on the type of claims that we had in the past. And these claims, they were either legitimate claims or fraudulent claims. And that is what we are trying to invest. If you already have this piece of information on a data set, if you have some information on your data set, that is called supervised learning. So we have something to supervise our research. We have something to supervise our learning. It's called supervised learning. So supervised learning is we have a target variable. And this target variable, it could be a binary, it could be trinary, it could be multi-class, it could be nominal, it could be a value, it could be continuous. Okay, so that is supervised learning. Supervised learning machine learning is when you have a data and you have a target variable. And what is a target variable? Is the piece of information about the data itself. Are you guys clear? The first part, machine learning, supervised learning. Are you guys clear?
I have a question. So in this example of the child, for the target variable, what would be that in this example? Pain or?
No, pain is a pattern. So let's say that you brought, 200 candles. Okay, 200 candles. Some of them they are flammable, some of them they are not, some of them they are small, some of them they are tall, red, color is different, the size is different, the shape is different, the corner is different, and they have different information. So, and in this specific example, there is no target variable. We're simply trying to explain the learning. Are you learning an object, or are you memorizing the object, or are you learning a pattern of the object? But if you were to use this as an example to make prediction, then we have to have a historical data. We need to have please hold on, ma'am. Please hold on. A historical data, and we need to have at least 200, 300, 1,000 candles. And these candles, we need to have information about them, their shape, their height, their color, their smell, year of made, material of made, and we could find if is it flammable or not flammable, is it real or a toy, something like this. So the target variable is flammable or not flammable, for example.
Okay, I get it now.
And now we have a historical data, and we want, of course, this historical data, which is 1,000 candles. Some of them they have some of them you cannot come close. Some of them you can play around. So can we find patterns? Can you dig deep into all this information about 1,000 candles and find a pattern that determines if a candle is stay away, you have to stay away, or you can, don't worry, you can play around. And of course we are gonna use supervised learning. Why? Is because we have all the information about this data, these candles, and also we have one little piece of information about these candles, and that is, are they flammable or not flammable? Are they real or simply a toy? You could bring your child an electric, not electric, a toy. It's a candle, and you switch it on and off. And when you turn it off, you are going to see the light, you are going to see the flame, but it's not burning. You can play around it, right?
Yes.
Yeah, then what do you think a child is going to do? It's going to stay away. It's a toy, but it's going to stay away. So we want to let the machine learning to learn patterns, but at the same time learn to differentiate between good patterns and bad patterns, good object and bad object. Clear?
Yes.
Good. So if you have that piece of information, then you are going to use machine learning that with the supervision machine learning. If you don't have the information, means if we have this data and we don't know if these claims are fraudulent or legitimate, we don't have any information whatsoever. Let's hide this for now. This is all what we have. So we cannot supervise. There is no way to supervise our learning. So in the first example, the machine learning already knows something about your data set, and based on that information, we are going to learn patterns and predict the future. And the second example, there is no target variable, there is no such information. So the machine learning is going to make an attempt, is going to try to find patterns. In the first one, we already know what to look at, and based on that, we are going to find patterns. And the second one, we don't know what to look at. We have no clue what we are looking at. We are going to make an attempt to find patterns. And these two different directions. And semi-supervised learning, it's very rare, and it happened when you have, if you have a huge data set. Part of that data set, we have the information, we know what to look at, and the second part, we don't know what to look at. And I'll give you an example. Let's say that two companies, they are making iPhones. iPhone A or company A and company B. So when they are making iPhones and they are selling iPhones on a virtual store, online store. So, and both they are doing very good, and they are doing very good business in terms of their revenue generated on the monthly, yearly basis. So company A, it does when it sells their product, they collect information on the type of iPhone, all the features of the iPhone, the information about their clients, the payments information. So they collected as much information as possible, and they have one piece of information about these iPhones. Are they used or new? Are they new phones or used phones? Company B, they are doing the same business, the same information, but they don't know. I mean, they forgot to collect the information about their phone as a new phone or used phone. And let's say that these two companies, they decided to merge, to work together and merge. So they merged, and of course they are going to merge their databases. And when they did, part of the data, we have the information about the iPhone, is it brand new or used, but the other part, there is no such information. So we are not going to use the supervised learning, because we don't have all the target variable. We are not going to use unsupervised learning because part of the data has a target variable. We are going to use semi-supervised learning. So we are going to deal with part with the target variable separately, and we are going to deal with the part of the data that does not have the target variable separately as well. Reinforcement is we don't have a data.
Now, one quick question before we move on.
Yes, ma'am.
So, it's my understanding based on supervised learning and unsupervised learning. So, I understand the concept clearly with the supervised learning. With the unsupervised learning, we don't know the target variable. We don't know what we need to do, right?
Right.
So then how are we going to analyze the data?
We are going to make an attempt.
Assumptions.
No, not assumptions. Now we are going to try.
Oh, okay. Try different analysis types.
Yes.
Oh, okay.
The supervised learning techniques, there are algorithms
Mm-hmm.
designed for supervised learning techniques. There are algorithms designed for unsupervised algorithms.
So I agree with that. So let's say, for example, there may be like thousands of like, algorithms for unsupervised learning. How do we know which one to use?
That is a future question.
Okay.
Okay, so
Okay.
we'll get there.
Okay. Thank you.
Okay, so when we are talking about supervised learning, let's now talk about supervised learning. So if you guys if you have a doubt on supervised learning, this is the time to clear your doubt. Otherwise, you won't be able to get it. So guys, yes,
Sorry.
yes, sir.
So for supervised learning, basically that information is captured by the company, whether that was a fraud or not a fraud.
Yes.
And that is captured by default. It's not like once we are starting a data site.
No, it's not by default.
Okay.
You could program it by default, but let's say that
Mhm.
you're working for this company for many years, and you're working for this auto insurance for many years, and now you are you want to apply. You heard about machine learning. Now you are a data scientist for the same company, and you've been trained. You have all the skills needed, and you suggested to the business to try machine learning. And of course, in the data, this is what you have. This is all what you have, and you don't know what is. You don't have a target variable. You don't have any information about this data, this past historical data. You don't have any information. We don't know if these claims were fraudulent or legitimate. Okay? And now you need to create that one feature. How do you do that? So you could investigate one at a time, one claim at a time. Go through that claim, determine if it was fraudulent or legitimate. How do you determine that? Of course, the business has some rules. Now you could go through their social media, and some of these clients would would share information. They would say, "Hey, I had a car accident. I lied, and they got a new car." So that is one way to determine if this incident was legitimate or fraudulent. This is one way. Another way is we are going to hire special. They have some third party. Their job is to investigate this type of this type of investigation. You could hire them. As some big companies, they don't do their inventory. They hire companies that specialize in doing such inventory, and I saw them like Home Depot. Towards the end of the year, they hire a company, and they do it overnight. They come with 50, 60 employees, and they scan everything manually they have in the store. You could do the same for this. You could hire a company that specializes in such investigations, and towards the end of the day, they are going to tell you, Mr. Mo, the first claim was fraudulent. The second one was fraudulent. The third one was legitimate. Fraudulent, legitimate. Here we go, all the way to the end. So now we have a piece of information we are looking for. You could program it if you have a logic, doable logic. You could say if the age was between and you might need to have some domain expertise in here. So your domain expertise, they already know that claims that being called on the weekends by younger driver, they are fraudulent. You could hard code in the SQL. You could simply create one feature and hard code it. If the color was at this point of time, it's legitimate. Otherwise, it's fraudulent, and you come up with your own target variable. There are many ways to come up with a target variable, but the most accurate way of coming up with a target variable in this case is to actually do the work, manually do the work, investigate manually. May take a month, it may take it might take a year, but at the end of the day, you are going to have an accurate target variable. And if you have an accurate target variable, of course, your prediction is going to be accurate.
Okay. So generally in like a bigger companies, if you're starting a data science project, so before this project is starting, are those like target variables are normally there, or do they expect data scientists, if they give them a business logic, to come up with that target variable? If it's a
in some of the project that I worked in the past, there is no target variable, and I come up with one. I'll give you an example. So let's say we got this data here, and I want to predict the type of the car that is going to be involved in a future accident. Okay, looking into the auto model, for example, and we got all these models. Okay, and let's say that I am only interested in Honda. I'm going to create one is Honda. Okay, I'm going to go through this. Is this Honda? No, we are going to put 0. This is a Honda. This is 0, this is 0, this is 0. This is a Honda. And go that way. Now we got a target variable. But I'm going to predict only if the future call is about the Honda, or is it going to be something else. So I was able to come up with my target variable using the existing data. Okay, folks, are you guys clear with brother asks about target variable? Are you clear about that?
Yep.
Explain to
Yes.
again, please, more.
So it depends on what you are trying to do. Let's say that we have this data and there is no target variable, and your manager asks you, can you predict the next call or the future call or future claim? Are they going to be from Honda drivers or non-Honda drivers? And we don't have any such Honda, non-Honda in our data. So we are going to use the auto model to make our target variable. We are going to go through all of these type of models, and we are going to set a 0 if it's not Honda and 1 if it's Honda. We are going to go through. So at the end of the day, we are going to have all zeros and ones. 0 if our model is Honda, and 1 if it's Honda. If this is what the business wants. The business wants to predict if someone's coming, what would be the type of the car that would have an accident tomorrow. If the business says he wants to or a year, so the business wants to predict if tomorrow's call, tomorrow's claims, it is going to be for cars that are 20 years old, or is higher than 20 years old, or less than 20 years old, or 5 years old, or new cars, or old cars. So we are going to create is it new or old? For example, is it new or old? And we are going to come up with the logic. Any car that was made in the last 3 years, it is going to be, we are going to give it a new, an N. Any car that was made in less than 3 years, we are going to make a new. above 3 years, we are going to get an O. So now we are going to have a lot of N's and a lot of O. And we are going to use that as a target variable to predict if the car that will be involved in tomorrow's accident is going to be a new car or an old car. We don't have that in the data, but we were able to extract our target variable based on the need of the business. Some of these target variables are easy to extract, but some of them are harder. Like, for example, you want to predict if tomorrow's claim is fraudulent legitimate. It's very hard. So you have to have a special method to extract the target variable first. Are you guys clear?
Yeah.
Good. Brother asks about the target variable. Are you clear?
Yes, brother. One other question. So normally, like right now, we are working on this particular file, right? So normally, do we have that much data enough to just do for analysis? Like for analysis, is that data enough, or do we need to always have a multiple files and a lot of data? I think for a better prediction, right? So
For better prediction,
right.
things we are looking for better prediction. This is rows. I'm sorry, this is columns, and this is rows. Okay, for better prediction, we need more rows and less columns. This is for better prediction.
Okay, and how about like if all the databases and data is in companies like some SQL database or wherever it is, then do we need to always ask somebody like DBA to put that data into a file? Is like file required to read all these data?
What do you?
Or it could.
What do you think?
I don't think so. I think both should be fine. Like even the file, or we can directly read it from the database itself.
So
and then
you have a team, all right?
Right.
What do you have in the team?
No, team would have like as you said, somebody from the database, somebody from the deployment, somebody from the business, right? These are the required people. So like if we are going and we are just giving them a requirement, okay, we would do the analysis and we require a data, and they say, okay, the data is here, this is the right data, but it's in our database.
So let me address that, brother. So the best data scientist is a data scientist who can conduct analytics, can fetch the data on his own, and have some domain knowledge. So all those three expertise within your team, you have them. That is the best data scientist, and it's really hard to find a data scientist who knows how to conduct analytics. He knows how to get the data and fish the data, and he has some domain expertise. And that's why we need to have a team. So the data could be scattered everywhere, and if you know how to get your data, you are better than a data scientist who does not know how to get the data. You are better than a data scientist who relies heavily on the team, especially DBA, to get him or her the data. So the data is going to be there, and your job is to get the data. How you are getting your data is totally your choice. It could be through your DBA, it could be through your own expertise, and the data, it could be in the flat. The business could provide you the data, and you could connect your Python and R to the server and select the data you are looking for.
Okay, so most of our analysis would be on, let's say, for example, on a Jupyter notebook. So what is good is just to have like a file-based data, or from the database directly itself. Is there like any preference from the data science perspective for the analysis to get it from fetch everything?
When you are getting the data, either you are reading the data from a file or reading the data from a database, you still need to create your own data frame.
Right. Yes.
Okay? And that data frame is a container that hosts your data. I'll give you an example. Let me stop here. Example. You import the library to connect, and then you are going to make a connection. And of course, you need to know the server you are connecting to. You need to have a username. You need to have the database name, and you need to have a password. Then you are going to do the select. Once you select the data, of course, you are going to store it. So this is the selection. Then you are going to store it into a data frame. You are going to store it in data frame. Here we go. You got the data frame. Okay, so you got the F stands for data frame. We are going to read using the SQL query, select, and whatever we pull from that server is going to be stored on the F. And now we are going to print the F. We are going to look into the type of the F, and we are going to do every possible thing that we could do from using the read from straight a file. Okay.
Yeah, thank you for clarification.
You're welcome. So again, we have a target variable. Then we are going to do supervised. And when we are talking about supervised learning, depends on the type of the target variable. If the type of target variable is binary, can anyone give me an example of a binary? What would be the value for binary?
0 or 1, like
Or
in
what?
the previous example, as you showed, like,
Okay.
if
How
it is
about
100.
trinary? Is it going to be 0 or 1
-1.
or 2? Multi-class is going to be 1, 2, 3, 4, and nominal. Nominal is going to be yes, no. So this is 1, 0, and 1. Give example. Fraudulent claim. Is it 0? Say it's legitimate. 1 is fraudulent. Trinary is, for example, happy, not happy, I don't know. Multi-class is satisfaction. Satisfaction always have a multi-class. And if you go to hospital and you are you cannot talk, they are going to give you a chart with 10 faces. They are going to tell you, can you point to the face that represents your pain? And you got 10 multi-class. So you got our data about the patients, about their pain, their age, and everything. And also in that data, you got some information about the pain. Is it hurt a little bit, hurts a little more, hurts even more, hurts a whole lot, hurts worse. So we got not only hurt or not hurt, but we have more than a level. We got multi-level or multi-class. And it could be a nominal yes or no, legitimate, fraudulent. So if your target variable is in this shape, in this type, in this format, we are going to do classification analysis. If your target variable is a continuous, is a value, like a dollar sign, a dollar, then we are going to do for example, house prices. You have 1,000 houses, and you have their prices, the price they were sold at. So the first house was 500,000. The second one is 510. The third one is 420, and you got 1,000 prices, and this is going to be regression analysis. So how do you determine if it's going to be regression or classification? Can anyone answer the question? How do you determine if you will be using regression analysis or classification analysis?
Based on target variable?
There is a target variable. And I think, brother, someone asked his question, how do you determine You got 1,000 algorithms. How do you determine which algorithm? You start with the target variable first. If your target variable is a binary or trinary or multi-class or nominal, we know we are going to use classification. Period.
Yes.
We are not going to use regression. And if your target variable is a value, is a number, is numeric, is continuous, we know we are going to use regression. If there is no target variable, and it's called, what do you call no target variable? What do we call this type of learning?
Unsupervised learning.
Unsupervised learning.
Unsupervised.
Yeah, we could use association rules. We could use anomaly detections. We could use clustering
Yeah. Okay.
analysis. And under clustering, we got number one, we got k-means clustering. Number two, k-mode clustering. We got hierarchy. Number three, hierarchical clustering. And we got many algorithms. Under regression, we got simple linear regression, multiple linear regression, polynomial regression. We got decision tree. We got support vector machine, and we got regularization, elastic net. We got the reach. We got many algorithms. And the classification, we got decision tree. We got random forest. We got bagging, boosting, logistic regression, naive Bayes. We got many algorithms. And so to determine what algorithms to use, number one, find out if you have a target variable. If we have a target variable, we know we are going to use supervised learning techniques. Which supervised learning techniques we are going to use, then we need to go down and look into what type of target variable that we have. If it's a binary or trinary or multi-class or nominal altogether or one of them, then we are going to use classification analysis. If it's not binary, trinary, multi-class, nominal, it's a continuous, then we are going to use regression analysis. Okay, folks, any questions, concerns, please?
It's clear.
Others, please speak out. Others, are we all at the same page?
Yes.
Yes.
Good. Okay, so let's.
Brother,
Yes.
sorry, quick question. So for unsupervised machine learning type, are we given like historical data?
Yes.
So we are given historical data. It's just we don't have a target variable.
Yes, ma'am.
Makes sense.
You are not going to learn. You are not going to learn if you don't have historical data. You are not. You need to have a historical data, and in that historical data, we need to have the best historical data is less columns and more. We need to have as many rows as possible, but we need to have less columns. And if you have more columns, then we are going to go through the dimensionality reduction process that we learned in previous phases. You need to do feature selections using the prior knowledge. You could use correlation analysis. You could use feature engineering like PCA, LDA, QDA, and other techniques. Clear? Okay, talking about that, this is what we covered. Yeah, so we just talked about this, a child and a candle. Okay, child saw a candle, and of course it's the child could learn two things, either an object or it could learn patterns that anything red and bright, things really hurt. And next day the same child was working in the kitchen, he saw the stove top. If the child learns the patterns, of course he's going to stay away. If the child learns an object, of course is going to try again and again and again. But this child, if you were to bring a child anything that is red and bright, regardless if it's hurt, is painful, is going to be a joy, still is going to stay away. And that is different than programming. On the other hand, if you ignore the you could program your child to do or not to do. I'm going to give you another example of, and we are going to stop here. So in the programming, we have the program, already programmed. We have a program in Python, in R, in whatever programming language, in Java, and we have all our our logic and hard coded, and we are going to use this the data, and we are going to find an output. We are going to find out an output here. We are going to find the target variable. So we got the data, features, and we got the target variable. So we got the program, we got the data, and the data is all the our insurance data except the target variable, because we don't have it, and we are gonna apply the program on that data to determine the target variable. But we are not learning; we are simply programming, doing some logics, and filtering out your data through those logics to come up with an output. And that is traditional programming. Machine learning is the opposite. We have a data and we have the target variable, and we want to learn patterns, a program of patterns or signals or the mathematical function. So the target variable is equal a function of all features. So this is the mathematical formula or mathematical equation we are trying to learn. If I have this mathematical formula already designed, I promise you, if you call me today to report a claim, I'm going to apply this mathematical formula on your data, and I would have an estimate. I would have a prediction on you. Are you lying or are you telling the truth? Now, another example, and we are going to stop here. So imagine that you are a fox. You are a fox, and you've been hired by lioness. They hired you, and this lioness, what it does is, now it's old. She's old, and when she was in power, she was strong and young. She used to find her prey very, very easy. Now it's old. I mean, she needs some help, otherwise she is gonna die. And back in age, sometimes she caught more than a prey in a day. And now it's gonna take her probably a week before she got one. She hired you. She hired you as a scientist, and she wants you to help her find prey. So that is the business problem. Business problem is helping the lioness find the prey. In the past, and this is most of the businesses before we implement data science. So we got, this is the business. Okay. And we are going to do effort 1, effort 2, effort 3, effort 4 before we got something. We are going to try so many things. We are going to try, so let's talk about BBDS. BBDS, we are going to try Tennessee market. Then we are going to try Florida market. We are going to try North Carolina market. Then we find out that doing business in Florida is better. So we did not come with that just randomly. We tried many markets before we determined the best market to do business with BBDS. And this is the traditional way. Now, this is how we are conducting a business without machine learning, without artificial intelligence. With this is without artificial intelligence. With artificial intelligence, this is the business. This is the business again. And I want to do one effort, but I'm going to do something 1, something 2, something 3, etc. So without machine learning, many efforts, finally you are going to get something. With machine learning, one effort, we are going to get so many things. And that is the difference between applying machine learning versus not applying machine learning. Anyhow, you've been hired as data scientist, and your job is to help the lioness make a better, utilize her power or her abilities to survive. So what do you think you are going to do? So you know the problem. The first thing first is learn the problem. What is the problem? And once you learn the problem, of course, you are going to spend time understanding what do you have the requirement. So you need to understand about the jungle, the weather, the size, the features, the animals live in that jungle, their size, their species, their type. You need to know as much as you can. And this is called, excuse me guys, historical data. Historical data. Okay? So now we got to collect the data. We have a problem. We understood the problem. Now we are going to acquire the historical data. And this historical data, it could be too much. It could be too little. It could be very good data. It could be very bad data. We don't know yet. At the end, we don't care yet about that. We are going to simply collect as much data as possible. In this case, the historical data is a jungle and all the information around it. Number 3, we are going to ask the lioness to give us her past incident. So we need to do some descriptive analytics about the past incidents of the lioness. So in other words, we need to make some supervised data. Out of this historical data, we are going to find data that are related to the lioness. And of course, we are going to label them. Is this a prey cut during the day, during the weekend? So we are going to get some information. So we are going to spend time applying descriptive analytics, statistical analysis, and exploratory data analysis. So far, so good.
One question here, Mo.
Yes, ma'am.
Like is the type of prey also matters in this case?
Yeah, I mean, yes, as much information as you can.
Okay.
As much information as you can, yes.
Thank you.
Anything matters. Anything matters. So now we got the problem, we got the data, we spent time understanding the quality of this data. We applied some descriptive analytics. So then we are going to apply machine learning to find the probability, to find the patterns. Okay, so we are going to learn some patterns. Patterns are all the hidden mathematical relationships. It's there, it's hidden, we cannot find it by simply scan through your data. We have to use some machine learning. And now we are going to make this prediction to find the best way to get the prey, and it's called optimization. So once we build our prediction, of course we are going to build as many models as possible. Depends on the target variable. We could build classification models, we could build regression models, we could build clustering models, we could build other type of models. Depends on the existence of the target variable, the existence of the data, the existence of target variable, and the type of the target variable, and the level of the target variable if it's classification. So once we build the models, of course we are not going to use all the models. We are going to use one model. This is the best model or the winner model. And this best model, there's always going to be a chance, always going to be a room for improvement. That is going to be, it's called optimization. So we build a model, we find out, so this is you, and this is the prey. Of course, the model would tell you, go up. If you go north, then cross the river, then go south, then cross a few trees, then you are going to be able to catch a prey. It's there. So it's a model. It's going to get you to the prey, but it's not optimized. can you get me to my prayer without going north and up and down, straight to the point? And yes, we could do that through optimization. And finally, once we have an optimized model, then we are gonna automate. We are gonna transfer into an automation. So in our example, we are gonna dig tranches and put it there, and the prey is gonna catch the prey automatically. So this is a mental picture of your day-to-day activities as a data scientist. Start with the business problem, then move into the data, learn about your data, do some descriptive, statistical analysis and data visualization, ADA. Learn about you as much as you can about your data, pre-process your data, build some predictions, optimize your winner model, and automate the winner model. And this could apply to fraud detection. And this our insurance. It could apply to any prediction models that you would be working at. Any questions, concerns, please?
I'm good.
Okay, so the rest is machine learning type. So we got the data, and we'll talk about this tomorrow. So let's stop here. We'll talk about this supervised learning, and tomorrow we are going to have an exercise. Tomorrow we are going to learn about the first machine learning, and that is decision tree. So this is, unfortunately, this is from the 30-week program. Enough algorithms that you could, if you want to learn them, you could be able to tackle any business problem. So in this 10-week program, we are going to simply focus on supervised learning. And what is supervised learning again? If someone asks you what is supervised learning, what would be your answer?
Like the data is labeled, like we have a target variable.
We have a target variable, that's it. So what is supervised learning classification?
If the target variable is a binary, like then we will use the classification model for the analysis or modeling.
The target variable has a value.
No, ma'am.
No, it's a binary, like, right?
It's either a binary or what?
Or a trinary, whatever.
Or
Or a nominal.
Yeah, no, or multi-class.
MC.
Okay, so you got supervised learning means we have a target variable. What type? If it's a binary, trinary, multi-class, nominal, is going to be classification. If it's a value, it's going to be regression. So tomorrow we are going to learn decision tree, then naive Bayes, logistic regression, and we should be done with the program. Unfortunately, this is a 30-week program, but we are going to simply give you a taste of what you expect from data science. Okay, folks.
So, quick question here, Mo. So, even after the program, like as I said, like I'm practicing on some data sets, should I still contact you? These questions or
yes.
Okay.
I don't charge. I normally don't charge anyone for anything for any help. I don't do it.
Yeah, thank you.
Thanks, either you are taking my
really appreciate your time.
Yeah, you are welcome. Either you are taking my programs or not. If you ever feel like you need help with anything, please reach out to me. I will be more than happy to assist you.
Brother, sorry, you can go ahead first.
So if you want to do the project for certification, we should let you know.
Yes, ma'am. That is, unfortunately, the certificate is costs some money for the business. If you want to do the project without certification, I can give you a project, but you have to pay for a certificate if you want it. It's through a third party, which we don't control. It does cost the business money. Yeah, if you need to work on a project, by the end of this training, talk to me. Then definitely we are going to sign a project to you with the certificate.
Thank you.
You're welcome. Okay, folks, that's it for today. I'll see you guys tomorrow. Until then, guys, evening. And bye, everybody.
Quick question.
Assalamualaikum, brother. You go ahead, sister. I will start.
Thank you. I mean, if we are going to cover it tomorrow, I mean, I was kind of confused about semi-supervised and reinforcement. I mean, if we are going to cover it tomorrow, I can ask tomorrow.
We are not going to cover them, and this is out of the scope of the program. And we are going to only cover supervised learning classification. But yes, tomorrow we'll go through that one more time. Yeah,
Thank you.
we got this type of. I think I got it somewhere here.
Yeah, maybe like in terms of like definition, if we
Yeah,
can
we'll
discuss
talk about it. Yeah, we'll talk about that.
Perfect. Thank you.
Yeah, welcome.
Assalamu alaikum, Masar. Can you suggest as a book that really talks about the various algorithm and its usage? I think you have a slide.
There's a lot of. I would recommend, brother, to go through. Number one, you need to understand data science. So I would recommend to read this book first.
Okay.
And I believe we have a PDF file.
Correct.
Go through this first and talk to me.
Okay.
Once you are done, reach out to me. I'll give you as many books as you want.
Sure. Thank you.
You're welcome. Okay, folks. Talk to you tomorrow. Bye, everybody.
Allah. Bye. Assalamu alaikum.
Assalamu alaikum.
Thank you.